Okay, welcome to part two. We were in the middle of solving an abstract problem here. We were trying to find the equation of a line in standard form, which has a particular given slope and contains a point. And so we had picked the point slope formula. We had plugged in the 6 for x. We had plugged in the 6 for x and the negative 2 for x0 and for y0. And we had plugged in the negative 1/2 for the slope. And then we were just in the process of converting that into standard form by getting rid of parentheses. And then we got rid of the fractions by multiplying by 2. And we were just about to add 2 to both sides to get x plus 2y equals 2, which would be the equation in standard form. All right, and that's what we were asking for, the equation of a line in standard form that had that given slope and point. All right, let's do a couple more examples here. Okay, so this one says write the equation of a line in slope-intercept form, which contains the point 5, 2, and is perpendicular to this line, 2x minus y equals 1. All right, well, I know that perpendicular lines have negative reciprocal slopes, so I'm thinking that I probably need to first find out the slope of this line so I can figure out the slope that my new line has to be, and then I can select an equation form. So let's start with the given line. Okay. I'll start with the given line. That's 2x minus 1 equals 3. And let's put it in slope-intercept form so we can read off what the slope is. So let's see. Subtract 2x from both sides. Negative y equals negative 2x plus 1. Then let's multiply everything by negative 1 so that we can change all the negatives to positives. And so we'd have 2x minus 1. So the slope here is 2. And so what that means is for my new line, I need this to be perpendicular to this line. So the slope here would have to be, let's see, the negative reciprocal. Well, first of all, it's negative. And if I think of this 2 as 2 over 1, then it would be 1 over 2. So I need the new line slope to be negative 1/2. All right. Let's see. So now we have our new line. Let's work on the new line. Well, the new line is supposed to be in slope-intercept form, so maybe we go ahead and write that out. And remember that I'm now looking for these two constants to fill in, right? Okay, well, I've just found out from the fact that it has to be perpendicular to this other line that the slope of the new line must be negative 1/2. So I'm going to substitute that in for the m. I'm substituting that in for the m. Okay, and I've still got one more constant that I need to find, right? I need to find this constant, right? But I could do that if I can find, for example, an xy value that must make the equation true, because I can substitute negative 5 and 2 in for x and y. So I'm going to substitute that in for x and y, and that'll let me find b, okay? So let's do that. Well, for x, I'm going to put the negative, or wait, for the y, I'm going to put the 2. And then for the x, I'm going to put the negative 5. Okay, there's only one letter left now, which is the constant b. Okay, let's multiply this fraction out. This is going to be negative times negative is a positive. If I put that 5 over 1, that's 5/2 plus b. All right. Let's get rid of all the fractions by multiplying everything by 2. So that's going to be 4 equals 5 plus 2b. And if I subtract 5, I'm going to get negative 1 equals 2b. And now if I divide by 2, I can find that b has to be negative 1/2. So the last step is I go back to this version of the equation where I knew that the m was negative 1/2, but I didn't know what b was yet. But now I know b also has to be negative 1/2. So I'll plug that in, and now I have an equation, and it's in slope-intercept form. So just to be clear what we did here, right, we took the given line and we found its slope because I needed to use its slope to find the slope of a line perpendicular. So I took a negative reciprocal, and that's what I plugged in for the slope in the new line. And then I plugged in the data point that had to make the new line true to find the last constant, which was b. This right here is a really good example of the entire procedure. Okay. Let's see, how many more examples? Just one more. Write the equation of a line in standard form, which contains this point and is parallel to this line. Try to pause the video, see if you can figure this out. Use the last example as an example to follow. It's similar. Okay, so for the given line, which is 4x minus 3y equals 6, I need to figure out its slope. So let's subtract 4x. I'm converting it to slope-intercept form here. Divide everything by -3 and get y equals 4/3 x minus 2. So its slope is 4/3. The new line has to be parallel to that. And I know that the new line slope therefore must be equal to the other slope. So I need to also have this new line have the slope of 4/3. Okay, so let's work on the new line now. The new line, we want it standard form. But I'm thinking, you know what? I'm given, now I have a slope and I have a point. Maybe I use point slope form here. Let's use point slope form. Right? The more you're familiar with these, the more adept you'll be at moving back and forth between different forms, whichever is appropriate. The reason why I'm thinking this is a good form to use is that we have a point and we have a slope, so why not use the point slope form? Okay, well, let's plug in 3 for y0. Right, that's this. Let's plug in, let's see, for the slope, we know that has to be 4/3 because it's parallel to the other line. And then let's plug in the 4 for the x0. All right, there's the equation, but it's not yet in standard form. So one last bit, I need to convert to standard form. Let's get rid of parentheses. 4/3 x minus, you know what, before we get rid of parentheses, why not, let's get rid of the fraction first. I've got that 3 on the bottom. What if I were to multiply the entire equation by 3? So everything is multiplied by 3. I have a 3 times this. But when I take 4/3 times 3, the 3's cancel and leave a 4 times this. Yeah, let's get rid of the fractions first. Okay, now I can get rid of parentheses by distributing. 3y minus 9 equals 4x minus 16. That's a little nicer, right? I want standard form, which means I need to have x's and y's on the same side. So let's subtract the x's. -4x plus 3y minus 9. 3y minus 9. Whoops. My board was wigging out here. So I've got -4x plus 3y minus 9 is -16. I guess I better get rid of the 9 on that side. So -4x plus 3y equals 9 and 7 is 16, right? So -7. And then wait a second, I need a leading positive. So if I multiply everything by -1, that's going to change the signs throughout. So it looks like the answer here is 4x minus 3y equals 7. That would be an equation in standard form that is parallel to this line, has the right slope, and it passes through this point because I used that point when I built the line in point slope form before I converted. Okay. All right. So there's plenty of examples to work on. If you want additional practice using the practice pages, definitely really look at these problems because they're a good lead-in for other things that are going to happen in our Algebra 3-4 or pre-calculus classes.